Industrial explosions have been a problem as long as man has been processing, storing, and transporting materials. In fact, the first documented industrial explosion occurred in a flour mill in Turin, Italy on December 14, 1785. Much has been learned about explosion phenomena since that first recorded event, enabling industry to develop fast, reliable protection strategies that not only protect lives and property, but a company's ability to operate and generate profits as well. The four components necessary to cause an industrial explosion are an enclosure, an oxidizer, like the oxygen in air, fuel, and an ignition source. These components are constantly present in many industrial processes, such as pharmaceuticals, agricultural materials, food products, chemicals, polymers, and metals. Explosion testing. The first step in obtaining effective explosion protection is classifying the explosion hazard. Every material has its own unique set of explosibility characteristics. Knowing what they are enables the system designer to select the most effective protection strategy. The most frequently used design data is the maximum rate of pressure rise, expressed as K maximum, and maximum pressure achieved in a contained explosion, expressed as P maximum. These data are typically collected through explosion testing in a 20-liter test sphere per ASME and ISO guidelines. Testing to determine minimum ignition energy, limits of flammability, or maximum oxygen concentration may be required in some cases to clearly understand the explosion hazard. Explosion venting. Explosion venting is often the first explosion protection strategy to be considered for outdoor installations. This method provides fast, reliable explosion pressure relief, preventing the destruction of process equipment or other enclosures. Explosion vents are lightweight, efficient, and non-fragmenting, even when exposed to the forces of an explosion. During venting, the maximum pressure of the explosion is reduced to a safe level, below the equipment design strength. The resulting vented pressure is known as P reduced. Explosion venting does not mitigate the effects of heat and flame attendant to explosions, nor the effects of ensuing fires. Flameless explosion venting. When process equipment is located indoors, one protection strategy is to duct the explosion discharge to the outside. However, this will increase the required vent area. Another protection strategy for indoor equipment is flameless explosion venting. Flameless explosion venting provides fast, reliable explosion pressure relief while retaining particulates and extinguishing the flame from the explosion. Flame Quench 2 has been tested and has been accepted by listing organizations in the United States and Europe. Flameless venting is an efficient way to reduce the maximum explosion pressure for equipment located indoors. Using Fike's Flame Quench 2, process equipment does not have to be located near outside walls to accommodate ducting and can be optimally located. Explosion isolation strategies may be combined with venting or flameless venting to prevent secondary explosions. Explosion isolation. Explosion isolation is an active system strategy involving detection devices, control equipment, and strategically positioned valves or chemical suppressant containers. Upon detecting the early stages of the explosion, gate valves are rapidly closed, or a suppressant material is quickly discharged to keep the flame isolated at its origin. Explosion isolation strategies are used to reliably prevent pressure piling and prevent the spread of explosions to other interconnected equipment. Unchecked, secondary explosions have resulted in the loss of human lives and the complete destruction of manufacturing facilities. Explosion suppression. Explosion suppression is an active system strategy involving detection devices, control equipment, and strategically positioned suppression containers. Explosion suppression systems will detect and extinguish the flames of an explosion in its very early stages, before destructive levels of pressure can be reached. Fike systems are able to do this faster than any other, due in part to our patented high-rate discharge containers and nozzles. Explosion suppression can also eliminate damage due to the heat and flame generated by an explosion, and is often the choice when the process to be protected is located indoors, and the material being processed cannot be released into the environment. Fike Total Concept Explosion Protection is the fastest, most reliable way to protect your employees, resources, and profits from the disastrous effects of an explosion. Our products have proven their effectiveness worldwide with successful installations throughout North America and Europe, as well as South America, Australia, New Zealand, Korea, and the Ukraine. Our protection equipment and strategies have been validated through extensive third-party testing with Factory Mutual, the SIBA explosion testing facility in Switzerland, and testing authorities in France and Germany. No other company is more qualified or better equipped to assist you than Fike Metal Products, a recognized world leader in explosion protection strategies. In fact, Fike is the only single-source manufacturer in the world that can offer total concept explosion protection. Solutions based on customer needs.